Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing very good. In today's session we'll talk about definite integrals bacha, only definite integral. We in the previous 5 sessions that we had for integration, we have talked about only indefinite integration, okay? So today we'll talk about from the very basics. We'll see the basic questions, how we can apply the concepts of definite integral on that, and in the coming session also we'll do some more questions on the definite integral, okay? This is again the part of your ongoing series which is 60 out of 60 in KCET mathematics in 100 days, okay? If you have not watched the previous sessions of integration, go ahead, watch all the sessions. It's there in the playlist for mathematics, okay? So I hope you are ready. I hope you are ready to understand definite integral. Take your pen and paper out. Let's start with the session, okay? So coming up next is what? First thing is, sir, the definition of definite integral. So if you remember, when I said, when we started the first session, when we talked about indefinite integral, okay? So first of all, we learned that there were, so in the integrations that we have, in the integrals, we have two kinds, okay? We had two kinds. Kind one was what? Indefinite integral. Indefinite integrals. Yes or no? Indefinite integrals. Same way we have to discuss today, definite integrals, sir. Definite integrals, sir. Okay? So if you remember, I said this, any indefinite integral will have what? Something called as integration constant. Constant of integration, okay? Because of that reason, the value of this integration will never be unique, sir. It will never be unique, okay? In the case of indefinite integrals, will not find any unique value because C keep changing as you change the conditions for the integration. Boundary conditions change for any particular given function, the C value will keep changing. Whereas in the case of definite integral, what we have, bacha? We have a unique value. We have a unique value, okay? So if you integrate the function fx, okay, in the range of a to b, where a is called as bacha, my lower limit. A is called as lower limit, sir. What about b, sir? B is called as upper limit of what? Of integration, okay? If you do this integration in this limit, in this range a to b, you will not get, you will get only a unique value. You will not get any random value. You will have only one value, okay? Now how do we find it? So if you take, let's say, after integrating the function fx, so I have a function fx, let's say like this. After the integration of this function fx, okay, what I get? I am ending up with another function f of x. So basically f of x is what? Integral of the function f of small f of x. Understand this? The capital F of x, or I can write it as g of x, any other function. This is the integral of the function fx. When that happens, I can simply put what? First upper limit in the function minus value of the function after integration in the lower limit. This is how we find the integration. So till this part, it is same as what we have learnt in indefinite integrals. What we learnt, sir, whatever are the formulas that we have, we'll use that and we'll find the integrals, okay, using all the different formulas, different rules that we have. So you'll do the same thing till this point. But after that, what are you going to do? Substitute the upper limit first in the function that you have arrived at the last, and then minus again the same function value at the lower limit. So f of b minus f of a, f of the upper limit minus f of the lower limit, okay? This is all right. Again, there's the understanding that if you find the integration of the given function fx, again any function will have what? Will have a curve, right? If it is a linear function, it will have a straight line. Quadratic will have a parabolic function, curve. So same way for a cubic also will have curve. Any function that you have, trigonometric, whatever the function is, exponential, it will always have a curve associated with it. Any function will have a curve associated with it. If you integrate that function in the limit of a to b, any value, okay, a to b, then what you're going to get? The result is nothing but area under the curve for that function in that particular range, in that particular limit, upper and lower limit. I hope you understand that, okay? So this is, from here only we have a chapter, right? Application of integral. We'll talk about this in detail in that chapter, okay? So right now just understand this. If I have any function, linear, quadratic, cubic, exponential, logarithmic, whatever function, trigonometric, for all the functions you'll have a curve, and if you integrate that curve or that function in a given limit, lower and upper limit like this, you will get the area under the curve. You'll get the area enclosed under the curve using that curve. It is these two boundaries. What is this boundary? Tell me. It's nothing but x equals to a line. What is it, bacha? This line is x equals to a line, right? And what is this line? X equals to B line. Why is that, sir? Because if you move across this line, you'll get every point x as B, and over here also you get x as A. So if you take the with x-axis with x equal to A line, so and x equal to B line and the curve, the area enclosed by these four conditions, x equal to A line, x equal to B line and the x-axis with the curve, you get that after integral of that function in the limit a to b, in the limit a to b. Okay, that's what is written here. See here, curve y equal to fx. So after integration, okay, you'll get the area bounded by the curve y equal to fx, the curve which is given for the function, and the straight lines x equals to a and x equals to b, and the x-axis Okay, so what? Let me summarize it for you. Definite integral will give me, first of all, unique value. Integrals give me in that limit for any function area under the curve. What curve? What curve? Like what area? Area enclosed by the curve itself, the two constant line x equals to a and x equals to b, which is the limit, and the x-axis. Okay, that's all. Let's move on. Let us see what is coming next. Fundamental theorems of calculus. We have two, first theorem and the second theorem. Okay, what does it say? Let f be a function. Means basically they're saying that for given function fx, and also we have another function ax, okay, both of them will be what? Continuous in the closed interval of a to b. Then I can write this function, area function, as derivative. If I differentiate area function, I'll reach where? I'll reach what? F of x for all x belonging to the same interval where this was continuous. Check here. F is a continuous function in the closed interval of a to b. How it is? Go and check how when we define the continuity in an interval for a given function. Okay, then I can have a function ax, okay, whose derivative will be equal to the function fx. Okay, means if I have a continuous function like this, bacha, then there might exist or there will exist a function ax, okay, whose derivative will be equal to what? The function fx. Okay, again in the same interval. Okay, first principle. Moving on to the second principle, second theorem of the integral calculus. Okay, second theorem of, what is it? Definite integral calculus. What is it? So check here. In this case, same things written. Isn't this the same thing what we did right now? So we can define this using this condition. Integral of fx dx. Okay, same things, upper limit value, the function value at upper limit minus function value at the lower limit. This is what? For what? For your definite integrals. Definite integrals. Okay, what's the meaning of this word? What's the meaning of this word? Antiderivative. Integrals, right? Derivative is what? Differentiation. Antiderivative will be what? Integral. What is this called as? Integrals. Same thing we have discussed in the previous slide. Okay, what is it, bacha? So f of x is the integral of the function fx, and this way, so this step is same as the indefinite integral part. Last step is f of b minus f of a, function value at the upper limit and lower limit. Okay, take the subtraction of that. All right, so let's move on to the question solving. Okay, the thing is, I have not taken very difficult questions. We have taken the trend. So a simple problem we have taken, and we'll solve all of them, but varieties are there, means from different functions we have taken. So this will recall some good concept from the indefinite integral also. So we'll see the questions, okay, and use the, basically we are trying to understand what here. Today's goal is very simple. We have to learn how to make use of, basically from very basics, from the very fundamental, how to make use of definite integrals, how to solve definite integral problems. Chali, first one. So the first question coming up is what? 3x cube minus 4x square plus 1 upon root x. Okay, so what I've done in this session, I've taken 10 questions. We'll solve all of them. Different varieties are there, but they are not very difficult problems, okay, that we have solved in particular functions or by parts. Simple problem we have taken, because our goal is what? To understand the concept of definite integrals from the basics, means how to apply this. Okay, that's our goal is. We don't have to talk about very complicated questions. That will come in the next session of definite integral. In today's session, we'll only talk about the concept that we have to use, how to use it, where to use it for a variety of different functions. So let's see this. Let us see this, bacha. First question. Okay, integral of this function between 0 to 1. How will I take this? So my step 1, if you remember, my step 1 is what? Find what? I. What is I, sir? If I take this integral to be I, this whole thing to be equal to I, okay, my first step is to do what? Is to find this integration for the function. So let's do that. Let us do that. How can I transform this function? I can divide the entire numerator by root x. I'll get 3 different terms. I can integrate individually. Let's see. So I can write this I equals to what? Integral from 0 to 1, okay, 3x, it's not x square, it's x cube, forgive me, 3x cube upon root x minus 4x square upon root x again, and then plus 1 upon root x. Yes, whole thing we have to integrate with what? With the variable x, so that's why dx we have to write. Please separate this integration. I get integration I is equal to, integrate I equal to 0 to 1, first one, 3 is the constant, I write it over here. If I divide x power 3, okay, and what is this? Power, I have to use what? Exponent rule for the division, okay. Remember this, x power 3, root x means what? X power 1 by 2. How much is that? X power 3 minus 1 by 2. How much is that? 6 minus 1 by 2, okay. How much is that? X power 5 by 2. Yes or no? Please check. X power 5 by 2. This will become what, bacha? X power 5 by 2 upon nothing, okay, because root x is gone now. I'll write with dx, write with dx. Next integration will be what? Minus 4 x power 3 by 2. Please have a look. Again same thing will do. I'll do what? 4 minus 1 by 2 will become 3 by 2. Again with what? The variable is x. Last one, plus 1, integral of what? Integral of x to the power minus 1 by 2 dx. Why so, sir? Because root x is there in denominator. It will go up, it will become minus 1 by 2, minus 1 by 2. Visible? Yes? Okay. Last part is not visible, sir. Let me rewrite it. No confusion is allowed. Okay, minus 1 by 2. All right. Okay, moving on. Let's integrate this. So integration I will become, I'll take 3 outside, it's a constant, okay. Integration of this will be what? X power n is the integration. What is that? Integral of x power n is, if you remember, x power n plus 1 upon n plus 1 or not? Yes. So let's do it here. Let's use it. So I'll get what? X power 5 by 2 plus 1 upon 5 by 2 plus 1. Same I'm going to do for the next one also, but with the minus sign. So minus 4 times of, please check, x power 3 by 2 plus 1 upon, okay, 3 by 2 plus 1. Yes, same I'm going to do over here, plus, okay, x power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1, okay. Now last step, which is very important. After integration, before integration I have to write the limit everywhere, 0 to 1, 0 to 1, okay. But after integration what I'm going to do? I'm going to put a big square bracket and write the limits as here, 0 to 1. Please check the next step, okay. Please check the next step. So what we're going to do? We're going to simplify the given integration that we have received from the previous step. What is it, bacha? It'll become what? 5 by 2 plus 1 will become what? Please have a look. My I will be 3 is there, okay. This will become 7 by 2. So x power 7 by 2. How much is this? Divide by 7 by 2, okay. Minus, what is this? 4 times of x to the power 5 by 2. Please have a look. 3 by 2 plus 1. How much is that? It's going to be 2.5. So 5 by 2, okay. 5 by 2 divided by, again what? 5 by 2. What is over here? Simply x power 1 by 2. So plus 1 upon 1 by 2, as this is x power 1 by 2. Limit will remain same, 0 to 1. Have a look, okay. So my I will look like this. If you remember, see this, 6 upon 7 x power 7 by 2. How much is this? 8 upon 5 x power 5 by 2. And how much is this? Plus 2 times of x power 1 by 2, 0 to 1. This is my integration, okay. What is the next step? Just replace this in this integration. Next step will be replace the upper limit and lower limit. So I'll get my integration I equals to what? Tell me. For upper limit first, I'll write everywhere wherever x is as 1, okay. So 6 by 7 times of 1 power something will be same 1. What is this? 8 by 5, 1 power something will be again 1 only. Okay, what is this? Plus 2 times of again 1 only. This is my upper limit. Okay, this is my upper limit. What about my lower limit? Lower limit, please check. Put 0 here. 0 power anything will be 0. Again 0, 0. So I can write here simply what? 0. Please have a look. I'll repeat. If you, this is for upper limit. This is for upper limit. This is for my lower limit. Please like 1 equals to here simply 1, again 1, again 1 with the same the coefficients. For 0, this will be 0 power anything, again 0, this also 0, this also 0. So this is the lower limit itself is 0. What is my answer? 6 by 7 minus 8 by 5 plus 2, right? Plus 2. So I can take the LCM as simply 35. Simply 35, correct? 7 and 5 LCM is what? 35. This will be what? 7 5s are. So this is simply 30, correct? 7 5 are 35, 6 5 are 30, minus 5 7s are. So this is going to be simply minus 56 plus 2. So this is going to be 70. How much is that? Please check. 100 minus 56. So 44. 44 by 35. My final answer. Have a look. Okay, have a look. I hope this is visible, all of it. For first step was to do the integration, very simple integration. Next step is substitute the value. Okay, moving on. Question number 2. Question number 2. All right. So whenever we look at this type of question, what is the first thing? Sir, rationalize it. If you rationalize it, the question will become very, very simple. Let's see. Let us see, sir. How will I solve this, sir? It will become, I'll take the rationalization directly. It will become 0 to 1. Okay. What is in the bracket? Just to be sure about it, we get what? 1 upon x plus 3, okay, plus x plus 2, okay, okay, like this. 1 second, 1 second. This is x plus 3 as it is. After rationalize this part, what I'm going to do? Multiply it with numerator what? X plus 3 minus x plus 2, okay, like this, and same thing over here. X plus 3 minus x plus 2 whole thing in this bracket. And this is what? Again dx is there. Dx is there. Dx is there. Let's see now. What I'm going to get? This I'll get it as 0 to 1 x plus 3 integral minus x plus 2 upon what? X plus 3 the whole square minus x plus 2 the whole square. Please have a look. So a plus b, a minus b. A itself is root of x plus 3. Okay. So this square will be a square. Same way over here, x plus 2 is b. So root of x plus 2 the whole square will be b square. Okay. Now what I'm going to get here? Please check. Dx will be there. I'm going to get what? I'll get this as integration of 0 to 1. 0 to 1. This will be, numerator will not change. X plus 3 minus x plus 2. Okay. Divided by what, bacha? Here simply x plus 3 and here minus of x plus 2 dx. Please have a look. Please have a look. X and x will cancel because there is a minus sign, and 3 and 2 will make what? This will make simply 1. Now please have a look at this part of the integration. Simply this will be integration of 0 to 1. I can separate this integration for this minus sign. I'll get what? X plus 3 in the root with dx minus 0 to 1 again. What am I going to get? X plus 2 in the root with again dx. Yes or no? Yes, sir. Let's integrate this. What is the integration of this? Simply the same formula. The power is what? 1 by 2. I'll write it as x plus 3 power what? 1 by 2 plus 1 upon 1 by 2 plus 1. Yes or no? Same thing over here. X plus to the power 1 by 2 plus 1 upon 1 by 2 plus 1. Whole thing is in the limit 0 to 1. The limit 0 to 1. Have a look this. This will become what? This will become 1 by 2 plus 1 will be how much? 3 by 2. So I'll get this as 2 by 3 in the same thing is here. Here also 3 by 2, here also 3 by 2. I can take it out. 1 upon 3 by 2 is there. Okay. And what is this? X plus 3 upon 3 by 2. Okay. Power 3 by 2. Here also what is it? X plus 2 with the power of 3 by 2. Okay. 0 to 1. Constant I can take it out. This will become what? Simply 2 by 3. Now please have a look. Okay. I'll put 1 first. What I'm going to get? I'll get 1 plus 3. So 1 plus 3 will be 4. 4 power 3 by 2. Then I'll put what? Minus sign. I'll put again 1. I'll get what? 3 power. 1 plus 2 is, this is 2 bacha. 1 plus 2 is 3. 3 power 3 by 2. 3 power 3 by 2. Alright. Now I'll put 0. So I get what? Minus sign. This is for upper limit. For lower limit I'll put 0 now. My lower limit is 0. It will become what? 3 power 3 by 2. Yes, please check. 0 plus 3 is simply 3. Power remains same. And minus sign is there. For this minus, I'll get what? 2 power 3 by 2. 2 power 3 by 2. Close this bracket. Okay. This is my final answer. I can simplify it. This will look like this. Please have a look. This is simply what? 4 square, right? I can write it as 2 power cube. Please check. 4 power 3 by 2. 4 is nothing but 2 square. So this 2 and this 2 will cancel. So I can write it as 2 by 3. 8 is there. Okay. I can just take this together. Minus 3 power 3 by 2 minus 3 power 3 by 2 will become what? Minus 2 times of 3 power simply what? 3 by 2. Okay. This is multiplication. Now last one with the plus sign, 2 power 3 by 2. Okay. I can simplify this, again, no problem, but I can take this as my answer also. Okay. Okay. Do one thing. Simplify this step. Simplify this step and give me the answer in comment section. Okay. Give final answer for question number 2. For question number 2. Have a look. 2 by 3 times of 8 minus 2 times 3 power 3 by 2 plus 2 power 3 by 2. This is okay. I hope everything is visible. Yes. Okay. Moving on. Question number 3. How to solve this? Find integral of 0 to pi by 4. The limits are 0 to pi by 4. Sine 3x, sine 2x. So to solve this question, we will need what? Remember this condition from grade 11 PU1. What is this, sir? Sine 2 sine C sine D. 2 sine C sine D. Remember this formula? This used to be cos of C minus D minus cos of C plus D or not. Yes. Okay. Over here I don't have this 2. So I'll write it as simply, I'll take this 2 over here, I'll write it as 1 by 2. Check here, there is no 2 here. I can take this 2 over here and write it as 1 by 2. So this integration will become what? Please have a look. I'll take this as 0 to pi by 4. This will remain. The limits will be kept as it is. I can replace this by, please compare. C is C, D is 2x. C is 3x and D is 2x. Forgive me. So I can replace this as 1 by 2. Okay. And this will become what, bacha? Cos of C minus D. How much is that? 3x minus 2x. That's simply cos of x. There's a minus sign and sum of that. So cos 5x. Cos 5x with what? With the variable which is dx. Separate the integration for both the terms. I can take 1 by 2 outside because that's a constant. Yes, 1 by 2 outside. Integrate what? Simply cos x from this limit. Next step, take a minus sign, integrate, again same thing in the same limit, but this time cos 5x is there, close the bracket. Okay, integrate this part. How much I'm gonna get? Cos x integration is what? Sin x, right? What is the limit? We'll see that. 0 to pi by 4, 0 to pi by 4. Okay, next part, minus, what is that, bacha? Simply sine of 5x, upon what? Upon 5. 5 will come, bacha, because cos ax differential integration is what? Sine ax upon 5. Okay, what is the limit here? Please check. The limit is again 0 to pi by 4. Close the bracket. Okay, please have a look. These are my steps. I hope you can see this. These are my steps. Okay. Next is 1 by 2 is outside. Let's keep it like this only. At pi by 4, what is that? Sin pi by 4 is, please check. Sin pi by 4 is how much? How much is that? 1 by root 2, sir. 1 by root 2. And what about lower limit? 0. So simply minus 0. Minus 0. Okay. What about this? Minus. Please have a look. Sin 5x. So what is this going to be? Sin 5 pi by 4. Sine 5 pi by 4. How much is that? Sine 5 pi by 4 is how much? Please check. 5x is there, no? Sine 5x means वो कम. Sine 5 pi by 4. What's the angle? 5 pi by 4 is this angle, right? It's nothing but pi plus, please have a look. I'm trying to explain you the quadrant rule over here for this particular question. Pi plus pi by 4, okay? Add this, you'll get what's the same angle. Which quadrant is this? Quadrant number 3, sir. Quadrant number 3. Quadrant number 3 is sign positive? No, sir, negative. So I can write this as minus sine. What is it? Simply pi by 4 upon 5. The limit will be there, 0 to pi by 4. Close the bracket. Okay? This is simple. Very, very simple, sir. Nothing else is there. Just the quadrant rule applied for pi plus pi by 4. How much we get the angle as? Minus sine pi by 4. Have a look now. The last. Okay? We are about to close this question. Let's see. 1 by root 2 will remain just as it is. 1 by root 2. Okay, minus 0 I'm not writing, just this minus. Now check here the bracket, please. Sine of pi by 4 will be what, bacha? I can take the 1 by 5 outside, no? I can take 1 by 5 outside. Okay, this will become what? This will become minus 1 by root 2, right? Because of this minus sign. And sine of 0 will be what? Okay, please understand this. 1 second. Yeah, I have not written this 0 part. I have already taken this limit, right? I don't have to write this limit again because pi by 4 is already considered over here. This will simply become minus 0 here. The lower limit also considered here because when I write pi by 4 means I have used the upper limit, right? So lower limit also have to use 5x means what? 5 times of 0. Sine 0 is 0. So lower limit is simply 0. Okay, chaliye. Moving on, I get what? 1 by 5 minus 1 by root 2, that is 0. Don't have to consider that. Let's have a look. 1 by 2, please, 1 by root 2 plus 1 upon 5 root 2 or not? Yes, sir. Okay, I have understood this. This is my upper limit part, this is my lower limit part. Okay, chaliye. How I got this minus sign? I explained you. We use the quadrant rule. Pi plus pi by 4, 5 pi by 4 will be what? Pi plus pi by 4, third quadrant. Sign is negative in the third quadrant. Okay, how much is this? This is going to be 6 root 2 upon 5. 6 by 5 root 2, sorry. Please check the LCM here. LCM will be 5 root 2. You have to add here what? 5 plus 1 will be 6. 6 is there multiplication. I have to cancel this. My answer for this integration is 3 upon 5 root 2. This is my final answer for the integration. Please have a look. 3 upon 5 root 2. Simple enough. Very simple question. Just use this formula. I said we'll take the different variety of the questions. Okay, formula will be there. Trigonometry, all the formulas has to be with you, bachcha. Okay, moving on. आगे बढ़ते हैं. Let's see this. 1 minus sine 2x integration with respect to what? 0 minus 0 to pi by 4. How will I do this? Again, I have to use the formula. Okay, I hope you can understand this directly by looking at the question. 0 to pi by 4 is there. Okay, now think about it. I have to take out the root. How can that work out? Only two possibilities are there for this function. I can use sine 2x formula. Okay, that is good thing, but also I can use one from the identity that we learned in grade 10. How much is that? Sir, sine square. Okay, I will need little bit more space, bacha. I'll need little bit more space, so let me write it over here. Okay, it's going to be what? Tell me. Integration 0 to pi by 4. Integral of the function in the interval 0 to pi by 4. Okay, this will become the root only. I can write this one as cos square x plus sin square x. Am I right? Yes, cos square plus sin square is 1 minus sin x is what, bacha? 2 sin x cos x. 2 sin x cos x. Okay, with again what? Dx will be there, the integration variable. What I'm going to get, please check. This will become what? Cos a square b square minus 2ab. A square b square minus 2ab, it becomes what? Please have a look. Pi by 4. This will be simply cos x minus sin x the whole square. Okay, dx is the integral variable like this. Okay, Now if I see this, what I'm going to get, please check. Integration of 0 to pi by 4 for what? Cos x minus sin x. Okay, let's integrate this. Let's integrate this. This is going to be cos x integration is what? Minus sin x. Okay, no, plus sin x, right? And what is this integration? Please check. This will become what? Minus cos x. Okay, so this will be simply cos x. Okay, from where to where? 0 to pi by 4. The limit 0 to pi by 4. Apply this. Apply this at pi by 4. What is the value? Upper limit sin pi by 4 plus cos pi by 4, and next one minus. Please have a look. Our lower limit I am doing sin 0, so 0, and cos 0, so plus 1. Okay, plus 1. Close this. Okay, so this will be what, bacha? It will be 1 by root 2 plus 1 by root 2 minus 1. How much is that? Please have a look. This is going to be simply 2 by root 2 minus 1. How much is that? Root 2 minus 1. Root 2 minus 1. My final answer. Our final answer for this particular question. Very, very simple. Why, sir? Why is this approach? Because of the square root. Okay, I had to make the perfect square to get rid of the square root. Okay, I hope this is visible. Everything. Moving on to question number 5. Okay, in this particular question, the limit is a variable a. The limit is the variable a. Let's see how can we solve this, sir. I have to integrate this, okay, without using limit first. Then I will apply the limit and we'll put that equal to the value 32, and we'll see which of the options are correct for the given function. Let's see how can we solve it. First, what is the first step? Find the integration. That is very simple over here. So if I integrate this 3x square plus 2x plus 4 from what? From a to 2 with what? With the variable dx, I can write this as, my integration I will be equal to what, bacha? This will be equal to, please have a look, 3x cube by 3, because x square will be what? X power 2 plus 1 upon the same thing 2 plus 1, so 3 over here, plus 2 times of x square by 2 plus 4x. Okay, this whole thing is under the limit a to 2. A to 2. Okay, simple enough. Please have a look. 3 goes out, 2 goes out. What I have left now? I equals to what? Please have a look. X cube plus x square plus x square plus 4x with a to 2. Apply the upper limit first. What is my upper limit? Please have a look. 2. We'll get it as 8 plus 4. 2 square is 4. And this is what? Simply again 8 minus lower limit. Please have a look. A cube, I put here a square and put here plus 4a. This is my integration. They have given this equals to what? They have given this is equal to 32. They have given this is equal to 32. Okay. Now do one thing. Take this whole thing equal to 32. I get what? This is what, picture 8 plus 4 is 12 plus 8 is 20. Okay. So simply I have 20. Can I bring this 20? Everything I'll bring on one side only. So I'll put here the LHS, I'll put it as 0. Please have a look. I'll put LHS as 0 because I'm bringing this 20 on this side of the equal to sign, and this also I'll bring on this side. I'll get what? Please have a look. I'll get this as 32 minus 20 plus a cube plus a square plus 4a. I'm bringing everything, 20 also on this side and this also on this side. Since it is negative, it will become positive. Okay, chali. How much is that? 0 equals to, this is simply what? 12 plus a cube plus a square plus 4a. This is my condition now. Now let's use the first one. If I use 1, it will never be like this. I'll get what? 1 plus 1 plus 1, always positive, can never be equal to 0. Use minus 2 now. Use a equal to minus 2. What I'm going to get, please check. This will be what? Minus 8. This will be what? Plus 4. This will be what? Again minus 8. How much is that? Please check. This will become what? Minus 16, right? And I have a plus 12 over here. Close this together. This plus 16, this is what? Minus 16. How much is the answer? 0. What's the option correct? B option is correct, sir. Okay. After finding my function, that relation for a, I substituted a1 first. We got not possible. Then I took minus 2. We got this as minus 8 plus 4 minus 8. minus 8 minus 8 is minus 16, 12 plus 4 is 16. The sum is what? 0. Means option number B. I have to find what? 0 only. Option number B is correct answer. Okay, moving on to question number 6. I hope this is visible. चलिए आगे बढ़ते हैं. Question number 6. Integrate the function dx upon 1 plus cos 2x with 0 to pi by 4. Okay, with the limit of 0 to pi by 4. This is simple. Yes. Okay, this is very very simple. Let's see. Again, use of the formulas of trigonometry. Okay, let's see. Integrate this integration I. My integrand I is equals to, the limit is given like this. Upper limit is pi by 4, lower limit is 0. Dx I'll keep as it is. Look at the denominator now. I can write 1 as cos square x plus sin square x. Yes or no? What about cos 2x? I can write cos 2x as plus cos square of x minus sin square of x. Yes, this is the formula for cos 2x. Yes, please have a look. Gone, right? These two are gone. What I get now? My integration I continues as 0 to pi by 4. The limits dx upon what bacha? Simply 2 cos square x. Take 2 constant outside like this. Integration of 0 to pi by 4. What is this? Take it upside in the numerator side. Sec square x dx. Cannot get simpler than this, right? 1 by cos square will become what? Sec square. I have taken 2 outside. My answer for this will be what? 1 by 2 is outside. This is simply tan x. Simply tan x from 0 to pi by 4. 0 to pi by 4. Okay. Substitute pi by 4. How much is the answer? Substitute pi by 4 for the upper limit. I get 1 by 2. My integration I is nothing but 1 by 2 times of pi by 4. So tan of pi by 4 minus tan of 0. Okay, sir. This is very very simple. This is 1 minus 0. How much is the answer? 1 by 2. Option number A. Please have a look. Please have a look. Okay. Simple integration. I have to do use substitution for the formula. 1 as x cos square plus sin square x. Second I use for cos 2x. I got it as cos square x minus sin square x. Okay. Use this cancelling, after cancelling this part, 1 by sec square as integration of sec square is what? 1 by cos square as sec square. Integration of sec square is what? Tan x. Substituting the limit, upper limit and lower limit, getting the answer as 1 by 2. Final answer is 1 by 2. Simple enough. Very very simple. Moving on to question number 7. So this is so again very very simple question. Okay. How will you solve this? Integrate this 0 to 1 e power 2 minus 3x. Okay. This will become, again with the dx will be there, will become 0 to 1. Okay. I am taking the integration directly. Can't write it again, sir. Okay. So what will this be, bacha? E power exponential function will remain as it is, but differentiate, but you have to divide it by minus 3. Because a is multiplied with x. What is that a? Minus 3. You have to divide it by a. Okay. So how much is that? 0 to 1 is the limit. Am I right? Yes. Let's take the constant outside. So minus 1 by 3 is outside. It's denominator, right? So I can take this as outside. Negative will go up. So minus 1 by 3. Substitute the upper limit. E power 2 minus 3. Because 3 into 1 is 3. So 2 power 3. And minus e power what? 2 minus 0. Because lower limit is 0. How much is that? Lower limit is 0. It become 1 by 3 with a minus sign. E power minus 1 minus e power 2. Take the minus sign inside. I'll get what? My integration I as simply 1 by 3 e power 2 minus e power minus 1. Any option like this? Any option like this? This is 3, okay? E power 2 minus e power minus 1. Option number B. Option number B, bacha. Very very simple. Moving on. Question number 8. Question number 8. I hope this is visible, right? Please have a look. Yes? Okay. Question number 8. Integrate sine of pi by 4 plus x by 2 from 0 to 2 pi. Okay. How will I do this? Very very simple. Same approach, exact same approach. Integration of sine is what? Integration of sine is 0 to 2 pi. Let me write the question first. Sine of pi by 4 plus x by 2 dx. Okay. This integration will become what, bacha? Simply cos with the minus sign pi by 4 plus x by 2, okay, divided by whatever is the coefficient of x. What is the multiplied with x? 1 by 2 is there. So divide everything by 1 by 2 in the same limit 0 to 2 pi, 0 to 2 pi. Take minus sign and 1 by 2 outside, is a constant, okay. So I can take this as, this is 1 by 2 in the denominator, right? It will become what? 2 in the numerator, so minus 2, and how much is this? Cos of pi by 4 plus x by 2 in the limit, what? 0 to 2 pi. Let's write for the upper limit first. I have the minus 2 sign, minus 2 as it is, outside as a constant. 2 pi by pi, how much is that? Please have a look. Cos of pi by 4 plus 2 pi by 2, okay, upper limit is done, minus lower limit, cos of pi by 4 plus 0, right? Okay, have a look now. Minus 2 times of, how much is this, bacha? Pi plus pi by 4, because 2 and 2 is cancelled, so pi plus pi by 4 is which quadrant? Which quadrant is that? Simply third quadrant. Third quadrant cos is positive or negative? Third quadrant says tan is positive, means cos is negative. So what? I can rewrite this as cos of pi plus pi by 4, I can write it as minus cos pi by 4. Cos pi plus pi by 4, remember this, cos of pi plus theta is what? Minus cos theta. Again the quadrant rules, okay, for trigonometry. Cos minus pi by 4, and over here simply cos of pi by 4. Yes, same thing is there. It will become what? Plus 2, and this is what? Simply cos of pi by 4. No, this minus, if you want I can write one more step. If you'd like I can write one more step. Write here minus sign, this is minus sign, okay. Now it will become what? 4 times of what? Tell me. Cos of pi by 4. Because minus minus will become plus, okay. 4 times of what is pi by 4? Cos pi by 4 is what? 1 by root 2. What's the answer? 2 root 2. 2 root 2 is option number D. Option number D. Very, very simple, right? 4 by 2 root 2 is what? 2 root 2. Answer is this. Have a look. Have a look. Okay. Moving on. Question number 9, sir. Question number 9. This is a good question. This is a good question. Let's see. Integrate cos x upon 1 plus cos x plus sin x dx with the limit 0 to pi by 2. Limit 0 to pi by 2. Let's have a look. How will I solve this? Take this integration, I equals to, same thing will take, substitute this as 0 to pi by 2, the limits cos x upon 1 plus cos x plus sin x dx, okay. Now, to make use of any formula I have to use what? I can use two formulas over here. I'll write all the formulas for you. One formula is cos 2x, okay. This is going to be a cos square x minus sin square x, okay. One more thing, 1 plus cos 2x, 1 plus cos 2x is what? Tell me. 2 cos square x, okay. From here only it comes. Now what about sin 2x? Sin 2x is 2 sin x cos x, okay. In this particular case, we don't have 2 x's, but we have x and x. So I can write this as in terms of x and x by 2. So please check this transformation of the given integration. This will become what? From the first formula, cos square x by 2 minus sin square x by 2. And what about this? This will become 1 plus cos x will become what? Cos 2 times of cos square x by 2. This will become what? Plus sign is there. So plus 2 sin x by 2 and cos x by 2, whole thing is with dx, okay. Now do one thing, divide everything by cos. Why? We'll see now. Divide everything by cos. If you do that, what are you going to get? Please check. This will remain as it is. It's pi by 2. It is pi by 2. Upper limit is pi by 2, bacha. Pi by 2. This will become what? Simply 1, because I'm dividing everything by cos square x by 2. 1 minus tan square x by 2. Tan square x by 2. Please have a look. cos square minus sin square is there. If you divide by cos square, it will become 1. This will become minus sin square by cos square, which is tan square x by 2. Divide this thing. If I divide by cos, it will become what? Simply 2. Okay, what will this become? Plus 2 tan x by 2. Why, sir? If you divide by cos square, one of this will cancel the square and sin the cos will become what? Tan. Okay. So let me just erase this part. I am writing this directly. I hope you understand. Okay, this is nothing but 2. Nothing but 2. Okay. So I get what? 2 plus 2 tan x by 2. Again, this is with dx. Okay, now have a look. I'll write it over here. Next step, I'll write this I as 0 to pi by 2, the limits of the integration. 1 plus, sorry, not 1 plus, 1 minus is there. I'll show you. Just give me 1 second. 1 minus tan square x by 2 upon 2 times of 1 plus tan x by 2 dx. Have a look. 1 minus tan square x by 2, 2 plus 2 tan x by 2. Okay. I've taken 2 common. Write this formula, a square minus b square. This I can write it as 0 to pi by 2, again this will remain same. 1 minus tan x by 2 and 1 plus tan x by 2. Okay, this whole thing divided by 2 times of 1 plus tan x by 2 dx is there. This goes out. This goes, whole thing goes out. Okay, not visible, looks confusing. Okay, let me change the color little bit. So I can cancel this whole thing with this whole thing. Okay, cancel now. Now have a look. What I am left with? I equals to integration of what? 0 to pi by 2 for the limits 1 minus tan of x by 2 dx. I can separate this integration. What I'm going to get over here? I'll get over this as simply x minus, this will become what? 1 by a. I'm doing for integration of tan x by 2. Remember this? Integral of tan x is what? It's going to be minus a log of cos x. Log of cos x. Right? This is the formula for this. Now over here I have what? I have tan ax, because this is x by 2, right? So integration of what? Tan of ax will be what? Tell me. Minus 1 upon a log of cos ax. Log of cos ax. Same thing I'll write over here. So 1 by a has come. So minus sign. Okay. And log of cos x by 2. Okay. This is it. And this whole thing is under what? The limit 0 to pi by 2. I hope you understood this. Okay. This integration of the tan a of x is nothing but 1 by a minus 1 by a log of cos ax. Okay. This will become what? Plus. So x plus 1 by a is what? 1 by 2, right? Sorry. A is what? My a value over here is what? 1 by 2. So I can write it as 1 upon 1 by 2. This 2 will go up. So I can simply write this as 2. 1 upon 1 by 2 is how much? It's simply 2. So 2 log cos of x by 2 in the limit 0 to pi by 2. Now substitute the value. I get what? I is equals to, for pi by 2, I'll get what? X as pi by 2 plus 2 log of pi by 2. How much is that? Tell me. Log of pi by 2. So log of cos of pi by 2 by 2, right? Yes. Now minus lower limit. Please check. For 0 for x will become what? 0 plus sign. 2 times of, have a look. 2 times of, this will be what? 0 log of cos 0. Log of cos 0 degrees. Okay. This is it. Please have a look. Pi by 2. What is this, bacha? Plus 2 log cos pi by 4, right? This is pi by 2 by 2. So pi by 4. How much is that? Okay. How much is that? That's going to be pi by 4. So pi by 4 will be what, bacha? Log cos pi by 4 is 1 by root 2. 1 by root 2. Okay. This is it. Now lower limit, this is simply 0, okay, and log of cos 0 is how much? 1. So log of 1 is again what? 0 only. So what is my answer? Please have a look. My answer will become pi by 2. Now 1 by root 2 is here, right? I can take this 2 over there, I can take this 2 over here. Coefficient of log will become power of the value, right? It will become what? Plus log 1 by root 2 the whole square. How much is the square of 1 by root 2? How much is square of 1 by root 2? Tell me this. Square of 1 by root 2 is, sir, simply 1 by 2. Okay. So I can rewrite this thing as square of 1 by root 2, I can write it as simply 1 by 2. Please have a look. This 2, which was coefficient of log, became what? Power. It comes here and becomes power, okay, like this. When I do that, I'll get what? Square of this thing. How much that will be? It will be simply 1 by 2. So log of 1 by 2, okay. I can write this as what? 2 power minus 1 again. I can write this as 2 power minus 1. This will become what? Please have a look. Pi by 2. 2 power minus 1 is how much? Minus 1 will come outside. It will become minus log 2. Confusing? Let me explain it over here one more time. So this is my final answer first of all. I'll show you why it is coming like this over here. Please have a look. So I'm getting this condition, right? I'm getting pi by 2 plus log of 1 by 2, okay. I can write this as pi by 2 plus log of 2 power minus 1, right? Because 1 by 2 is nothing but 2 power minus 1. I can bring the power to the coefficient. So pi by 2 minus log of 2. I hope you understood this, how I wrote over here. Pi by 2 plus log 1 by 2 is pi by 2 minus log 2. Option number pi by 2 minus log 2, okay. Oh, there's 1 by 2 missing. I had 1 by 2 somewhere. Okay, yeah, this 2 that I took common. I had a 2 over here, right? This 2 I did not take it common. So this 2 will be over here, bacha. This 2 is a constant, right? It is common everywhere outside. Everywhere it is common, okay. It's a constant number. 1 by 2 is outside. This 2 times of, check here, 2 times of 1 plus tan square tan of x by 2 is there, no? So this 2 is common. This is multiplied with, whole thing multiplied with 1 by 2. Let me write it as 1 by 2. Very, very important. Sorry for missing it out. So option number, this C. 1 by 2 pi by 2 minus log 2. 1 by 2 pi by 2 minus log 2. I'll again let you see it. First of all, we had to use the transformation for using formulas of cos and sine. We use all the 3 formulas given here. We transform this function as 1 minus tan square x upon 1 plus tan square x by 2 like this, okay, not a square, 1 plus tan x by 2. Using the formula of a minus b times of a plus b, we got rid of 1 plus tan x by 2 in the denominator, okay. Then this was simple integration, okay. How did we do this integration of tan x by 2? Using this formula, okay. This is over here like this, this is over here like this, alright. Now from here, we got this integration, substituted the value of pi by 2 and 0, and after using the upper limit and lower limit, we got the condition as 1 by 2 pi by 2 minus log 2, okay. My final answer is over here. My final answer looks complicated, but this is your final answer, okay. Please accept. 1 by 2 pi by 2 minus log 2, okay. Moving on. Question number, please check option number C was correct. Question number 10. Question number 10, okay. Again, how will I solve this, sir? They have given, after integration with the limit 0 to b, I am getting the answer as 4 by 3 root 2, okay. What is the value of b? Asking what is the value of b. How will I solve this, sir? First thing is very, very simple, do the integration. Root is there, so I will rationalize it, okay. 0 to b, 1 upon 1 plus root of 1 plus x minus root x, rationalize it, 1 plus x plus, again, this thing in the root, and this will be what? Same. This whole thing with dx, because integration is with the variable dx, what I am getting here, 0 to b, okay. Please have a look. The numerator will become what? Root of 1 plus x plus root x, yes, divided by square of this, right? A square minus b square, whole thing with dx. So 0 to b, this is what? Simply 1 plus x plus root x divided by what's 1 plus x minus x dx. X and x are gone, sir. X and x are cancelled, sir. What I'm left with? Check here. I is equals to integration from 0 to b. This is under root 1 plus x, okay, plus root x with the variable dx, okay. Let's integrate this over here only. I get what? I'll get this as 1 plus x, okay, root will become what? 1 by 2, right? Root will become 1 by 2. So I can write this as 1 plus x to the power 1 by 2 plus 1, 1 by 2 plus 1 divided by same thing 1 by 2 plus 1, okay. Over here also same thing, plus x to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. This limit will same as 0 and b. Limit is same as 0 and b. Last question, so just the last few minutes to solve this problem. What is this 1 by 2 plus 1? 1 by 2 plus 1 is 3 by 2. 1 by 2 is 0.5, 1 is just 1, so 1.5 is 3 by 2. I'll take 1 by 3 by 2 common. 1 is denominator, right? So 1 by 3 by 2, please have a look. I'll take what common? 1 upon 3 by 2 I'm taking common. Sir, over here same thing. Same thing is there, sir. Please have a look. Yes, same thing is there. So if you look at this, what I'm left with? I'm left with 1 plus x to the power 3 by 2 plus x to the power 3 by 2, limit 0 to b, This is my integration I, okay. So this will become what? Have a look here. This will be I equals to 1 upon 3 by 2 will become what? Will become 2 by 3. Will become what? 2 by 3. 2 by 3, okay. This is under integration. So 1 plus x, I'll write this as it is first. 1 plus x to the power 3 by 2 plus x to the power 3 by 2, limit 0 to b, okay. Now have a look, put this with b value. My I equals to 2 by 3, so 1 plus b to the power 3 by 2 plus b to the power 3 by 2, okay. B to the power 3 by 2, this is upper limit. What about lower limit? Minus 1 plus 0, simply sir 1, okay. Simply 1 power 3 by 2 plus 0 I'll put for x, so simply 0, correct. This is my lower limit, upper limit minus lower limit. Have a look. So my I will become what? 2 by 3, so 1 plus b will remain as it is, 3 by 2. This will also remain as it is, 3 by 2. Now how much is this? Please check. Minus 1. Because 1 power anything will be 1 only. There is a minus sign, so minus 1. They have given this integration. I is equal to what? 4 by 3 root 2. They have given this is equal to 4 by 3 root 2. Please check. I can cancel this 3 with this 3 and this 2 with 4 as 2. What I'm going to get? 1 plus b 3 by 2 plus b 3 by 2 minus 1 equals to, what's left here? 2 root 2. So this is my final condition. 3 by root 2 is here, okay. All right. So let's look at the options now. Options are 8, 4, 2, 1. Simplest substitute is what? 1. Let's check with 1 first. We might get the answer directly from there. So I get what? 1 plus 1. I am putting what? B equal to 1 over here. 1 plus 1 power 3 by 2. What is this? 1 to the power 3 by 2 minus 1. How much is that? In the LHS, please check. This is going to be simply 2 power 3 by 2, okay. And this is simply 1 minus 1. How much is that? Cancelled. And how much is this? 2 cube. 2 root is what? 2 power 1 by 2 is what? Root 2. Root 2 cubed, right? Root 2 cubed. How much is that? Simply 2 root 2. This is equal to what? To the RHS that I have over here. It means for the value b equal to 1, the condition is valid. Okay. So option number D is correct. Option number D is correct, sir. Okay. What is the answer? Please have a look. 1. B equals to 1 is valid. For b equals to 1, this condition can be giving me the result of 4 by 3 root 2. I hope everything is visible over here. Have a look once again. Yes. Yes, sir. So this was it for the basics of definite integral. We'll come up with another session. In that session, we'll talk about more complicated questions, advanced level questions, okay, which will be dealing with your KCET ready problems. So in the next session, we'll deal with the definite integral, and do not forget, after so this completes, once we complete the definite integral and the properties of definite integral, this completes your integration. But this is not over. We'll solve, I think 3 to 4 sessions will take to solve questions, revision on all these topics. So we'll take questions on all these topics. Very good questions I've taken. You in the next sessions, after the next session, you'll have 3 or 4 sessions. In that, we'll talk about only practice of the questions of each topic. I'll tell you which topic is that, and we'll solve questions on that particular topic, okay. And then we'll solve some PYQs also. So I think after this coming session, you'll have 3 to 4 sessions of just practice of questions. So do not, don't forget to be there and solve all questions with me. I will take only 7, 8, 10 questions per in every session, because the questions will be lengthier. So we'll solve all the 7, 8 questions, learn and revise the concepts again and again, and then we'll move on and complete the chapter integration, okay. After this, what we have left, we have, I think, the last chapter of the integration calculus which is left for the PU2 is AOI, right? AOI is left. So that's why it becomes very, very important to conclude this on a high note, okay. A lot of challenges are there for all of the students, so I understand that. Any other queries, any other doubt, any other feedback about me, make sure that you comment in the, let me know in the comment section. I try to improve and get better and try to, make it more and more helpful for you in the coming sessions. So with this, I would like to end the session. I hope all of you learned few things, okay, in the classes that I've solved, all the questions that we did. With that, keep working hard, have positivity around you. I'll see you in the next session. Please take care of yourself.